Now the multiplication algorithm. Now we will see how multiplication algorithm works. So we have two numbers, 50 and 12, and we are multiplying these two numbers, right? So the input size is 2. The input numbers is 2. In multiplication, we know we multiply every digit from every other digit. Like 2 will be multiplied by 0 and 5, and then 1 will be multiplied by 0 and 5, right? So let's multiply these two numbers. 0 2 will be multiplied by 0, it's 0, and 2 will be multiplied by 5, it's 5. And the second number is then we leave the first number. The second number is 1. 1 when multiplied by 50, it will be 50. 5, sorry, 0 and 5, right? And then we add these two numbers and we have 550. Okay, so the input numbers are 2, and total multiplications we did was 4. Let me increase the input size. If we have 500 and then we are multiplying it by 120, so how many multiplications will be? Now we have 3 digits, right? So we have 3. In total multiplication, 0 will be multiplied by 3, 0 will be multiplied by 500, 2 will be multiplied by 500, and 1 will be multiplied by 500. So the total multiplications will be 9, right? Let me increase the input size again. If I am writing 5000 and I am multiplying it by 1200, how many multiplications? There are 4 digits, right? And the total number of multiplications is 0 multiplied by 5000, 0 multiplied by 5000, so it is something 16, right? Because it's increasing by the power of 2, right? If we have 4 digit number, the total number of multiplications we will do, we have 2 4-digit number, and the total number of multiplication we need to do will be the square of that number, right? So we have 4, square of the 4 is 16, like we did in the 3. When we had 3, then at that time the total multiplications were 9, the square of that number. So the complexity is increasing by the square of that number, right? So in multiplication, you line up the numbers, take the first digit in the bottom number and multiply it in turn against each digit in the top number, right? And so on through each digit. What we do is we take the first digit in the bottom number and multiply it in turn against each digit in the top number. So and so on through each digit. So to multiply our 3-digit number, we must do 9 multiplications as we did, right? And if we have 200 digit numbers, we need to do 10,000 multiplications. It's increasing by by the power of 2. It's a quadratic increase. So the point here is, if we have 100 digits, then we'll have to do 1000 multiplications. If we have 1 million digit numbers, and then the result will be of 10 raised to power 12 multiplications. As the algorithm scales with n squared, this is O of n square, or the quadratic complexity. The complexity of multiplication is quadratic, right? The addition was the linear complexity, and this is quadratic complexity because the number is input size is increasing. We are increasing both the input size and sorry, this is addition, right, this one. So if we are increasing the number, then the complexity is increasing by the power of 2. So with the help of multiplication, we or the multiplication algorithm is giving us the complexity of n square, right? The input size, we represent the input size with the help of n, right? So the complexity is n square, and the short form is something this, right? Okay, now we completed the multiplication, and the complexity we have is of n square. Now let's come to the division. We have a problem, and what we are doing is we have a phone book, and we need to find a name. I need to find a number by the name. The name of the person is Qasim, right? Here the name of the person. The name of the person is Qasim, and the phone book is sorted by the alphabetical order. We know phone books are sorted using the alphabetical order. So I have a table here with the alphabets A to Z, and here are their sequence numbers 1 to 26, right? So we need to find Qasim. The strategy we will use will be of division strategy, right? In the division strategy, what we will do is, let's say we have this number, this list of number, and we will divide the input. This is the input, and this is our data. So we will use the division strategy here, and in this we will, let me just make it bold, this line. Okay, now it's clear, right? So the strategy, our strategy is simple. We will take the first letter from the name Qasim, it's Q, and we will divide this data into two halves, right? We have numbers 1 to 26, so the middle number is M, the middle letter is M. Now here you will see, is the letter Q comes before M or after M? We know Q comes after M. So in this slot, right, in this region we can find Q. In this region we can find Q. So now let me write down the steps. Yes, steps, right? And the total input size we have, which we denote using, you can see n. The size is 26, right? Now in first step, what we did, we divided our list in two halves, and then we examine that on which half our letter Q will be. So we found out that it will be on the right hand side. So this is step 1, and then we have reduced our input size, right? So now in this half we will again divide it by half. So 14 from 26, so the middle number is T. We will divide into half, and now we will check on which side the Q will be. The letter Q, we can find the letter Q. On which side we can find the letter Q. So we know that the Q comes before T, right? So we will shrink our input size, and now our problem space is this one. So this is, we have did the second step. Now we will implement the same strategy. We will divide this space into two halves, right? So now we have p as a middle element. Okay, right? So now we will check, is the letter q is present on the left hand side or the right hand side. So q comes after p, so we know that the this, we will focus on the right hand side, right? So now we will shrink, or you can say we will divide this into two, and here we are, right? So, and then we will add one more step. We did. Okay, and now the middle is r. Now the q comes after r or before r. We know q comes before r, and now we got our required result, which is q, right? So in 4 steps we got the required result. We divided the list into half, half, half and half, and we searched the number, right? So in 4 steps, right? Let's say we have another name, which is Muhammad, and we want to find this name, that we want to find a number whose person name is Muhammad. How we will do this? We will use the same strategy, and now you will see the difference, that with the input size Muhammad, with the required result Muhammad will find out in just as fast as possible. So what we will do, we will divide our list into two halves, and this is the middle element. Now we will check, is the middle element has the same letter that we are searching, and yes, it is. So now how many steps we did? We did just one step, right? So this is the best case. We will see what the best case and the worst case are. So as you saw, finding Qasim, the strategy took 4 steps, and finding Muhammad, the strategy took just one step, right? So this is called binary search. We used the strategy binary search. We will look into the search in depth when we will talk about trees. So don't get confused, or don't worry what the binary search is. Just remember it, that it's a binary search. This technique is called binary search, in which we divide our problem space by half, and we keep on dividing it into halves until we get the result. So this is called binary search, and is used in everyday programming, right? If you want to find a name in a phone book of 1,000,000 names, you can actually find any name by doing this at most 20 times. In comparing each algorithm, we decide that this comparison is Rn. In comparing each algorithms, we decide that this comparison is Rn. So we implemented this on a problem space, and we got the result. Okay. So what is the complexity now? The complexity is logarithmic, right? So the bigger term, this is of O of log of n, or you can say logarithmic complexity, right? So now the logarithmic in question could be, okay, with logarithms, we know that logarithm works on base. they have a base of 2 or 10 or 5, whatever you want to give them, they work on base. So normally when you are working with your calculators, the base of the logarithm is 10, but in computer science or in binary search or in these kind of search, we assume that the base is 2, right? To know more about logarithm, if you are not familiar or you need to refresh your understanding of logarithm, because you must have learned about the algorithm in your school life, but as for those who are not who want to refresh their mind, they can use this link mathisfun.com/algebra/logarithmic logarithms.html, or also they can view the Khan Academy's video, which is very helpful to you. So the complexity of this method, or you can say this problem, is logarithmic.